Okay, we're going to talk about lesson 13 and lesson 14. First, starting with lesson 13, calculating and comparing square roots. So you'll be able to calculate, approximate, and compare square roots. So here we see the different vocabulary. So perfect square, remember, if we take the square of an integer, we get a perfect square, right? So like 1 squared is 1. 1 is the perfect squared. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square, so on and so forth. The radicand, basically what we see here is if we have just our square root symbol, so this is our square root symbol, also known as a radical. Basically what we see here is the radicand is going to be the numbers and or the variables that live underneath our radical. So if we have a radical here, this is going to be our radicand here. Again, basically the square root symbol, it's asking us what number times itself gets us the radicand. And just another reminder, so if we have the square root symbol, remember the number that lives on the shelf, we call that the index. And again, it's just implied to be 2 if there's no number shown, because it's saying what number times itself 2 times is going to get us the radicand. So let's say we have something like this, square root of 16. This is the same thing as this. It's saying what number times itself twice gets us 16. If we're thinking about the principal square root, that number is just 4. All right, let's move on here. So if we look at this here, basically we talked about the perfect squares. See if you can list the first 15. So we have our square root symbol, our radical. We already talked about the radicand is the number and or variables that live underneath the radical. So we see those there. Here, what we can see is we go ahead and see all of our first 10 perfect squares right here along this diagonal, just where, again, where we have, let's just say 10 and 10, where those meet, that gets 100. That's going to go ahead and be one of our perfect squares. But yeah, we have all of our perfect squares in the diagonal right there. All right, so basically, let's say we want to estimate here the square root of 50. So what we see here is we know that 7 squared is 49, and we know that 8 squared is going to be 64. So we see when you take the square root of 50, we're not going to get a nice, easy integer that we're going to work with. It turns out we're going to get a decimal number, in this case, a non-rational number. So what we see here, 7 squared is 49, 8 squared is 64. So what we see here, we can go ahead and say square root 50 is closer to the number 7 because 50 is closer to 49 and 64, right? So it's going to be about 7, even though it's just a little bit more than 7. All right, last thing here on this lesson, so we look at this question here. So looking at the area of the dance floor is 289 square feet, and we know it's in the shape of a square, right? So basically we know the formula of the first square is area equals the side length squared. So we know the area is 289 square feet. So basically, in order to get rid of this exponent of 2 here, I have to go ahead and take the square root. Whatever you do one side, do the other side, right? So therefore, the square root of 289, that's 17. Square root of feet squared is just feet. So we see the dance floor is just 17 feet by 17 feet. All right, so that's it for lesson 13. Let's go to move on to lesson 14, determining the theoretical probability of an event. So let's go ahead and take a look here at this. So if we look at this lesson here, we're just trying to calculate probabilities of simple events. And so what we see here is we just have some vocab here. Oops. So looking at some of the vocab, just sample space, those are all the possible outcomes of an event, right? So if we roll a number cube that has 6 sides, we have outcomes of 1, 2, 3, 4, 5, or 6. Those are all the outcomes, right? A simple event, that's just an event that has only one outcome. So let's just say here, for example, rolling a 5 on a number cube, that's just an example of a simple event if we're thinking about rolling a number 5. All right, theoretical probability. So basically it's the ratio of favorable outcomes to possible outcomes, and then complement is basically the set of all outcomes in an experiment that are not in a given event. So let's just say we have, we want to figure out what is the probability of some event, like let's just say rolling number 2 on a number cube. Basically, if we add all the probabilities of not rolling number cubes, so the probability of rolling a 1, 3, 4, 5, or 6, we see that those probabilities will go ahead and add up, in this case, to 1. So basically, that's just our vocab for this lesson. Let's look here at theoretical probability. Again, that's what we think is going to happen. So again, that's just before we do any experimentation, we just go ahead and calculate mathematically, what do we expect to happen? And so we just go ahead and do, again, this is just our generic formula here for our probability, just the number of successes all out of the total number of possibilities. Okay, so if we're thinking about a regular number cube or die, basically if we're thinking about what is the theoretical probability of the following, go ahead and pause the video so you can work on this, and then we'll go ahead and talk about it. All right, so basically what we see here, probability of 6 is just 1 out of 6, probability of 2 is 1 out of 6, probability of 7, there's no 7 on a number cube, so just 0 out of 6 or just 0. An even number, there's 2, 4, and 6 out of 6 numbers, so that's just 1/2, 3 out of 6, which simplifies to 1/2. Probability of a number greater than 3, we know that would be 4, 5, and 6. That's going to go ahead and be half of the numbers on a number cube. Probability of a number less than 5, that's 1, 2, 3, and 4. That's 4 out of 6, or simplified 2 out of 3. Okay. All right, so moving on here, looking at this last example, in a bucket there are 10 balls numbered as follows. So here we have a couple ones, 2, 3, and then 3 4s, a 5, and then 2 6s. So we're just going to go ahead and choose a ball randomly from the bucket. So we want to figure out what's the probability of drawing a ball with a number greater than 4. So let's go ahead and figure that out first. So probability of we'll just say greater than 4. So what we see here, if I go ahead and highlight these, it looks like there's 1, 2, 3 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 3 out of 10, or if you want to express it as 30% or just 0.3, that's totally fine. Now let's compare that to drawing a number greater than 4 or a 1. If we look at the probability of a 1, what we see here for a 1, we have 1, 2 out of the, let's see, 10, so 2 out of 10, so that equals 20%. So it turns out in this case, we have a greater chance of drawing a number that is going to be greater than 4. All right, so this was lesson 13 and then lesson 14. Yeah, so again, let me know if you have any questions. Thank you so much. Have a great